Okay, you guys need to go get out your notes from last time. Your 3.4, 3.6 day 1 notes. You need to flip until you see this page. I know that this is the day 2 video. It's because we didn't finish these examples from the day 1 notes because it was just too long for day 1. So go until you find this page from your day 1 notes. And we actually did finish this day 1. This is the last example we did last class. Pause if you need to. Okay, then scroll down to the bottom of the page. We're going to start with this example. So again, keep in mind this is from the day 1 packet. Alright, so this is asking us to find all real zeros. And what you'll notice as you're working the day 2 questions, they're just going to ask you some more complicated questions. So instead of asking for all zeros, they'll ask for all real zeros. Or they'll ask for all rational zeros. So from last time, what you should be picking up on is that if I want to find all the zeros, I would first try to set it equal to 0. Okay, then I would ask myself if I could do AC factoring, but I can't because it's not quadratic. And it doesn't have 3 terms. Then I would ask myself if I could do grouping, but I can't because it has 5 terms. So that's why we learned last class about this whole P over Q thing. So if I can factor for P all the factors of the last constant, 10, so plus minus 1, plus minus 10, plus minus 2, plus minus 5. And then I can factor for Q all of the factors of the leading coefficient, so plus minus 1. And these would be all of my options for rational factors. And what this list really means is plus minus 1, plus minus 10, plus minus 2, plus minus 5, because when I divide each of those by 1, I get the same thing. So then you would take this list, you would plot P of x in your y equals on your graphing calculator. And you would look for x-intercepts on this list. Because you need to know a place to start. And if you're trying to find x-intercepts on your graphing calculator, you do second trace, and it asks you about finding zeros. Okay, so you do all of that, and you should be coming up with a couple of different options. You should see that -2 and +5 work. Doesn't make a difference which one you start with. You guys have more room on the next page as well when you run out. If I just started with -2, so I'm going to do synthetic division with the one that I see that works with the P of x that I have. So I make sure that P of x is in order, which it is, and I make sure that there are no missing terms. So I write my coefficients: 1, -5, -5, 23, and 10. Bring down my first number, start multiplying, and then I add with synthetic division, so I end up with -7. Multiply and get 14, add, get 9. Multiply, get -18, add, and get 5. Multiply, get -10, add, and get 0. Then we talked last time that this always bumps down a step in degree from your original, so this will be x to the third, x squared, x, and then this is your number. You have to actually verify that you get a remainder equal to 0 because that means it goes in evenly and that means you have a factor. So you must make sure that you verify that. Well then, we have to talk about how we use all this information. So we know how we use the bottom information. The number in the box really meant that we were dividing by x plus 2 because we always change the sign of the number in the box. So instead of our original 0 equals equation from the p of x part, we've turned it into 0 equals x plus 2 times the quantity x cubed minus 7x squared plus 9x plus 5. We know one answer is that x equals negative 2. But for all of this, we would now have to keep going to try to solve the cubic. And last class we saw one of these, and it had 4 terms, and so we tried grouping. As you try that, we would have x squared times x minus 7 plus, and then there's nothing in common between the 9 and the 5, so plus 1 times 9x plus 5. These don't match. And this is the first time so far in this book, in this class, that we've seen it where it's impossible to factor with our techniques that we already know. So since they don't match, no, we can't factor by grouping. And that's our next challenge on the next page, is to solve the cubic. But I can't factor by grouping. So if I turn that over to keep solving, now I'm interested in solving 0 equals x to the third minus 7x squared plus 9x plus 5. Well, if I'm out of options as far as factoring, then I can do p over q. So p over q for this one would be all the factors of 5, so plus minus 1 plus minus 5, because 5 is my constant, and then plus minus 1 on the bottom for all the factors of my leading coefficient, which is 1. So now I can graph this on my graphic calculator and look for x-intercepts that are on my p over q list. And I'm talking about this p over q list, not the original one. And I should end up seeing that 5 is an option. So then that's what I'm going to do with synthetic division. I'm going to put 5 in the box. I'm going to make sure it's in order, which it is. So 1, negative 7, 9, and 5. I would fill in any missing terms with zeros. Bring down the 1 and multiply. So 5. Add these, so negative 2. Multiply, so negative 10. Add these, so negative 1. Multiply, so negative 5. And again, I'm checking that my remainder equals 0 so that I know that it goes in evenly, so that I know that I have factors and zeros. So if I were to keep working, this means I was dividing by x minus 5. And then this answer means that it's 1x squared, because I jumped down in degree, minus 2x minus 1, which is my number. So I've now turned this equation into 0 equals x minus 5 times x squared minus 2x minus 1. So I know that one answer is x equals 5, on top of my answer from the last page that was x equals negative 2. Then I'm down to this part that's quadratic. And so I would try to factor with AC method. But AC is negative 1, and there's nothing that works with negative 1 to get me to negative 2. And you might say, oh no, now at this point I've got to do P over Q again. That's 3 times in one problem. You don't have to do it again because it's quadratic. Why don't you complete the square? Or do a quadratic formula. And you guys need to practice this because last time you really struggled, and instead of working your way through it and looking at notes, you just stopped. So you need to practice that you can do each of those methods. I'm going to show quadratic formula because we did a bunch of completing the square in class. So quadratic formula on that would be x equals negative b, so positive 2, plus minus square root b squared, so negative 2, quantity squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2a, which is 1. So x equals 2 plus and minus the square root of 4 plus 4 all over 2. So that's square root of 8. And if I'm working with the square root of 8, then I can clean that up. 2 plus and minus 2 square root of 2. All over 2. And then, as we've talked in Math 110, if you see something that's divisible in each of the slots on top, and the slot on the bottom, then that's how you know to go ahead and reduce. So divide all those terms by 2. Get 1 plus or minus square root of 2 all over 1, and so at that point you could just do 1 plus and minus the square root of 2. So let's keep track of all of our answers. Here are 2 answers, 1 plus and minus the square root of 2. Coming back up a little bit further, x equals 5. So now I have 3 answers total. If you look back at your original problem, I need to have 4 answers total. And if I go back to the last page, that's my 4th answer. So I have 3 answers on this page, and then stepping back a page, x equals negative 2. That's my 4th 0, my 4th answer. Okay, excuse me. Going back to directions, pay attention to the fact that this question asked for all real zeros. We actually just boxed in all of the zeros, so we do need to spend some time making sure we pay attention to that. We are only going to keep real answers. Well, negative 2 is a real answer, so I can keep that. And as I keep scrolling through, 5 is a real answer, so I can keep that. And as I keep scrolling through, this is where a lot of times you would get imaginary answers, but 1 plus and minus the square root of 2 is a real answer, so I can keep that as well. Okay, next question, they're switching it up on you and asking for only rational zeros. So applying that to the last question, if I only wanted rational zeros, I would make a note that this last one we found, or the last couple that we found, are not rational. Because the square root of 2 is not a rational number. It's not a fraction. Its decimal does not end or repeat. So it's not a rational number. So we wouldn't keep that in our final answer. Now if I try to approach this question, this new question, the x to the 4th, I would try AC. That doesn't work because there's not 3 terms. I would try to group. That doesn't work because there's not 4 terms. So I would do P over Q, P being where I factor the constant, plus minus 1, plus minus 9, plus minus 3. I don't have to write it twice, just 3 and 3. That's fine. And then I factor the leading coefficient. So plus minus 1, plus minus 2. Then I graph P of x, and I look for x-intercepts. And I should be seeing that negative 3, 1, and 3 work. So I can pick any of those that I want to start with. And if you each pick a different one, your in-between work would look different, but your final answers would look the same. Excuse me. So if I just pick negative 3, I need to make sure that I have all the terms and that they're in order. And I do, so I write all my coefficients. 2, negative 1, negative 19, 9, and 9. I break down the 2. I multiply and get negative 6. I add and get negative 7. I multiply and get 21. I add and get 2. I multiply and get negative 6. I add and get 3. I multiply and get negative 9. I add and get 0. And that's a good thing. I'm checking that the remainder equals 0 so that I know that I have a 0 and I know that I have a factor. And now I need to pay attention to where this number came from. So if I'm having a negative 3 in the box, that really means I'm dividing by x plus 3 where we change the sign. And then my answer goes down in degree. So I started with the 4th degree, so this will be 2x to the 3rd minus 7x squared plus 2x plus 3, which is my number part. Sorry, my pen's spazzing out. Okay. So let's write that equation that we have. So 0 equals, sorry guys, give me a second. There, no, come on. It's not working. Great. Okay, let me try to undo all of this. The pen doesn't hold a charge right now. Okay, you might just want to pause your video or fast forward until I get this fixed. Alright, I'm just gonna pause. Okay, I was able to charge the pen for a little bit. I'll see if this works. Okay, so we did our division. Now, we set our equation equal to 0 because we're trying to find zeros. We turn this division work into our factored form of our original. So I divided by x. I divided with the negative 3, which really meant I was dividing by x plus 3. Then my answer, 2x cubed minus 7x squared plus 2x plus 3 is my other factor. From the x plus 3, I know one answer is negative 3. From the cubic, I now check it has 4 terms. I hope that I can do grouping. So I check that. But anymore, now that I know that it doesn't always work, I would just think through it in your head to see if those parentheses are going to match. So if I take out x squared, get 2x minus 7, then plus 1, and I'd have 2x plus 3. No, it's not going to work because the parentheses don't match. So then my option is to do p over q for the cubic. So if I go to the next page, I can't remember if you guys actually have. I'm sorry, you don't have enough paper on this one. I just wasn't able to update these before I needed to make your copies. So okay, if we have the 0 equals for the cubic, 0 equals 2x cubed minus 7x squared plus 2x plus 3, and that wasn't able to be grouped, so I do p over q for it. And p would be the factors of the last term, plus minus 1, plus minus 3. The constant term, sorry, it's not always last, but the term that doesn't have an x. And the q is factors of your leading coefficient, the coefficient that's in front of the variable with the highest power, plus minus 1, plus minus 2. And now I graph this equation. I graph the cubic, and I look for x-intercepts that are on my current list. And you should be coming up with, at this point, that positive 5 will work. Oops, hold on. I need to make sure I'm looking at the right example. Not to positive 5. Positive 5 wasn't even an option for our rationals. But once you graph, you should be coming up with the fact that x equals 1 works and that x equals 3 works. You can pick either one of those. So say I pick 1. And now I'm going to do division with this cubic. So 2, negative 7, 2, 3. And I go through, drop the 2 down, multiply, add, I get negative 5, multiply, add, I get negative 3, multiply, add, I get 0. And I'm checking that because I want the remainder to be 0 so that I know that I have a 0 and I know that I have a factor because it goes in evenly. So what that means, it meant that because of the 1 in the box, I was dividing by x minus 1. And then I interpret my answer, 2x squared minus 5x minus 3. So now I take the cubic equation that I have, and I can rewrite it as 0 equals x minus 1 times 2x squared minus 5x minus 3. So from the x minus 1, I have the answer that x equals 1. And from the 2x squared minus 5x minus 3, I start off and try AC method. And it hasn't been working, but that doesn't mean that I don't keep trying. So I get negative 6. In this case, it actually does work. I can do negative 6 and positive 1. And I can go all the way through AC method because I have a constant in front of my x squared that's not 1. So 2x squared minus 6x plus 1x minus 3, factor by grouping, 2x out, x minus 3, plus 1, x minus 3. This does work because those parentheses match. So x minus 3 is a factor, and 2x plus 1 is a factor. So if I set those equal to 0, I end up getting x equals 3, and x equals negative a half. And now if I count up all the zeros that I have, right here I see that I have 3 zeros, but overall this was a 4th degree polynomial. So I should have 4 zeros, and my 4th zero was way back up at my first division step, x equals negative 3. They're all 4 zeros. Now I need to go back and pay attention to their special direction, and their special direction was that I should only keep rational zeros. We talked in our last example, excuse me, that 1 plus or minus the square root of 2 is not rational because the square root of 2 is not a rational number. But negative 3 is a rational number, so I'm going to keep that. 1 is a rational number, I'm going to keep that. 3 is a rational number, I'm going to keep that. And negative 1/2 is a rational number. Any fraction is a rational number. Any decimal that terminates, that stops, or that repeats is a rational number. So I have 4 rational zeros here. And this finishes out your day 1 packet, but it's really part of your day 2 objectives that I need you to be able to do more complicated day 1 questions. Well, these are more complicated day 1 questions. Now, flip over to your new notes packet that the sub has given you. And I don't have the fancy cover page on my version that I had at home. So you should have 3.4, 3.6, day 2 is what you should be seeing. And it should be the fancy page that has an entire page for EQs and for your summary. Okay. Your essential questions here will be, how do I find all zeros of a polynomial, which I asked you last time. But what makes it day 2 is that finding all of the zeros when multiple steps don't factor. That's what we've just been working on. So I want you to summarize the last two examples from 3436 day 1 notes packet, because that's what we've been doing for 3436 day 2. I'm sorry that your photocopy just wasn't split up in the right way. Okay. Then beyond that, how do I find only rational zeros? How do I find only real zeros? Because they asked you just for some tricky directions. And again, that's going back and summarizing those last couple examples that we just did. Okay, for this packet, the essential questions you need to focus on for this packet is just one thing. How do I take zeros and generate polynomial functions? So they're giving you the answer, and let's go ahead and clarify polynomial functions in standard form. So review of that vocab. They're going to give you the answers that we've been finding. You're going to have to turn those answers into factors and then multiply everything out to end up with a polynomial that we've been starting with. So as you flip over, this is something we've already done. This is what we've already done. Okay, we don't need this information because we already did it on your fancy cover page. And we'll start right here. We've been talking that if x equals 5 is a 0, then x minus 5 is a factor. Well, we need information about when I have imaginary answers. And so that's what the conjugate zero theorem talks about. That if a plus bi is a 0, a minus bi is a 0. So we need to pay attention that imaginary solutions come in pairs. And we know that because when I get an imaginary answer, I'm getting it from square rooting a negative. And so I'm ending up with the positive and the negative version, because when I square root both sides of an equation due to absolute values, I end up with a plus and a minus. Okay, so let's work on this idea, and then you're done. And you'll find this idea much simpler. It might take you a while to multiply it all out, but it's otherwise much simpler than the last two examples that we've been doing. Excuse me. Okay, they want a polynomial function in standard form with integer coefficients that satisfies the following. So really, I just need to pay attention to this whole standard form part. The integer coefficients will take care of itself. So I need to know that I have degree 4, so they tell me that R is degree 4. Okay, then let's make a listing of my zeros. So one of my zeros is that x equals 1 minus 4i. Then I'm going to leave some space. X equals negative 3. Oh, and they tell me that negative 3 has a multiplicity of 2. And then they tell me that the coefficient, so I'm going to put that up here with R, degree 4, and coefficient of x cubed needs to equal negative 8. For right now, I'm going to look at this whole 0 idea. I'm going to say, wait a second. One of the zeros they gave me has an I, so that means that x equals 1 plus 4i also works, and they're just not telling me that. And then I should pay attention to the fact if it's degree 4, I should see 4 pieces of information setting here, 4 zeros, 4 factors. Well, I can come over and say, okay, here's 1, here's 2, here's 3. Where's my 4th one? That's this multiplicity of 2 idea. That means that it's negative 3 twice. Okay, let's turn all of these into factors. So if x equals 1 minus 4i is a factor, then it's x minus, in parentheses, 1 minus 4i. I think I misspoke. If x equals 1 minus 4i is a 0, then x minus the quantity 1 minus 4i, so big parentheses, that's a factor. Then if x equals 1 plus 4i is a 0, so then x minus the quantity 1 plus 4i, big parentheses, that is a factor. Then the x equals negative 3, so that would be x plus 3. And I said it has to happen twice, so rather than writing it twice, I could just write it with the squared. Or you can write it out 2 times, doesn't make a difference. Okay? Alright, now let's clean this up. So this means x minus 1 plus 4i. The second one means x minus 1 minus 4i. And then the last one, x plus 3, quantity squared. You are going to FOIL, so you actually might want to write it out twice. And then what I would do if I were you, I would FOIL these. And I would do box method if I were you. You always want to FOIL your conjugates, your i's, together because they're going to cancel nicely. And then since this one was a squared, I would FOIL these together. You don't necessarily need box method for that. Then you put it all together and you multiply it out one more time. So let me show you what that looks like. You do have more room for this on the next page. I don't know how much room, let me see. Not a ton, so I'm going to do my box method just on this last page. Okay, so x, oops, I'm sorry. I'm going to go back to the black one that I was working on with the i's. So x minus 1 plus 4i. And then x minus 1 minus 4i. And then I multiply. X squared, negative x, 4ix. If you do it right, your i's should cancel because they were conjugate pairs. Negative x, positive 1, negative 4i. Negative 4ix, positive 4i, negative 16i squared. Okay, if I go back through, this is a good thing, and my pen is needing to charge again. I'm really sorry, guys. I'm going to pause. Okay, so then, as I was talking about, we can see that as I come up here, negative 4ix and 4ix cancel. And then positive 4i and negative 4i cancel. And I squared is really negative 1. So I've turned this entire part that I had to FOIL out with i's into x squared minus 2x plus 1 plus 16 when you multiply negative 16 and negative 1 plus 16. And then I have the part about FOILing out x plus 3, x plus 3. And you can go off to the side and do that. You should have an okay time at this point knowing it's x squared plus 6x plus 9. They said standard form, so now I take these two and I FOIL them. And I would do the box method if I were you, just because it organizes everything. So if I write those out, so I'd have x squared minus 2x plus 16, x squared plus 6x plus 9. So x to the fourth when I multiply across the top, minus 2x cubed, 16x squared, 6x cubed minus 12x squared, 16 and 6. I'm really tired, I'm sorry. 16 times 6, 96. Then 9x squared minus 18x, and then 6 and 9. Sorry, 16 and 9, 144. And then I add those up. So all of this is equal to, and I don't really get canceling there, but that's okay because I don't end up with any i's left, so that's fine. X to the fourth plus 6 minus 2, so plus 4x cubed. Add up all your x squareds, 9 minus 12, so negative 3, and 16 minus 3 is 13, x squared. 96 minus 18, so 86. Hold on a second, I apologize. Alright, excuse me. 96 minus 18, so plus 78x plus 144. Okay, so this is a polynomial that's in standard form based on those zeros. And it's a degree 4 polynomial, and that's what I would expect as I go back up and double check all of my conditions. Okay, yes, I made a degree 4 polynomial. Is the coefficient of x to the third equal to negative 8? Well, as I go back down here, coefficient of x to the third is not equal to negative 8. I want this to equal negative 8. So basically what that means is if I called this f of x, this isn't the right one that they want. They want a polynomial r. Well, r is going to equal f of x times negative 2, because if I multiply this 4 by negative 2, I will get negative 8. So I need to do that for the entire thing. I need to multiply the entire quantity of f of x by negative 2, and that's how I would get r of x. So r of x would be negative 2 x to the fourth minus 8 x to the third, and that's what they wanted. And then continuing to multiply by negative 2, negative 26x squared. 78 and 78, so 140, 156 minus 156, x minus 288. This is the polynomial that they want. Degree 4, and it has the proper coefficient for x to the third. Okay? This was just continued from the last page. Okay? Then one more example of that. You guys should be able to pause this and go through and do it yourself and check that you're actually getting it, that it's making sense. And then come back to the video once you have a solution. Okay, so they're telling us degree 4, standard form. So turn all these zeros, x equals negative 2, x equals 0, x equals 2, x equals 4. I need to turn those into factors. So x plus 2, we switch the sign. X, because x minus 0 is just x still. X minus 2, x minus 4. I would rearrange that if I were you. So I would put the single x first, and then x plus 2, x minus 2, because those are going to be nice to FOIL out, and then x minus 4. I would FOIL those x plus 2, x minus 2 first, get x squared minus 4, because your outside and inside terms are going to cancel. Then you have the x in front, then you have the x minus 4. Okay, at this point I would FOIL these two. So I would get x squared minus, x to the third minus 4x squared minus 4x plus 16. And then again, just remember you have an x in front. So x to the fourth minus 4x cubed minus 4x squared plus 16x. Okay. Then we go back. So this is a polynomial. This could be like f of x. But then I go back and check all the conditions. They wanted degree 4. Okay, great. They wanted the coefficient of x to equal 48. Well, as I go check, the coefficient of x is 16, and I want this to be a 48. So in order to make that happen, I want to look at 3 times f of x. So 3 times all of this. And that would be my final answer. And I'm going to go up in this space up here and write it because I'm just out of room. So this would be like our p of x for a polynomial. 3x to the fourth minus 12x cubed minus 12x squared plus 48x, making it have the proper coefficient that they wanted. The only other thing I have to add for you on a question like this process is that sometimes they're going to give you a graph, and that's how you're going to have to pick out your zeros. And so if they've given you a graph and you want zeros, you're going to look for x-intercepts. That's only going to find the real zeros. The imaginary zeros aren't going to show up that way, so they'd have to give you information about imaginary zeros. But sometimes you have to find your own zeros by looking at the graph. Okay. Last question. We're not going to do the word problem handout. We'll have to address word problems when I'm back with you next week. Okay, so this graph, degree 10, is shown. Determine how many real and how many imaginary solutions the polynomial has. So we've got to think about, if I know it's degree 10, I need a total of 10 zeros. Let's see what I can pick out from my graph. Well, I can pick out -1 as a zero from my graph. I can pick out 0 as a zero from my graph. I'm looking at x-intercepts. And I can pick out 2 as a zero from my graph. That looks like I only have 3 zeros. Well, I need a total of 10. Really, with multiplicity, though, I have more than 3. So I need to think about, because I see that -1 bouncing off, it must have a multiplicity of 2. Because it bounces, but it doesn't flatten. If it bounced and flattened, then I would say it was a multiplicity of 4. I know it's an even multiplicity because it bounces. Since it just turns right around, I know it's just multiplicity of 2. 0 is just a multiplicity of 1 because it crosses straight through but doesn't flatten. So because it crosses but doesn't flatten. 2 has to be what kind of multiplicity? It crosses. So it should be an odd multiplicity. But it does flatten. So crosses and flattens. So multiplicity of 1 is not going to cut it. That means it's got a multiplicity of 3. Well, so then all of this means if I added these up, so with multiplicity, I have currently 6 zeros. So if there are 6 real zeros, and there are 10 total, then that means there are 4 imaginary or complex zeros. Okay? To make the 10. So let's see about answering their question. How many real and how many imaginary solutions? 6 real solutions, 4 imaginary solutions. And that's it for your day 2. I know in the subs instructions I included that watching the day 1 video was optional and you need to watch the day 2 video. That's because I was originally staying home because Gideon got sick yesterday at daycare and can't go to daycare. As you can probably hear from me, I am sick and I just cannot record a video for day 1 at this point. If I feel better throughout the day before 4th block, I'm happy to record it and put it up here for you. But it's just going to depend on how I'm feeling and how Gideon's feeling. So you have your notes from last class. You know how to do day 1. And really with the first examples that we did today, that should solidify day 1 for you. Work in your groups. Work together. Help each other. You know what you need to know to be able to do both day 1 and day 2 assignments. You're not going to like them that much because they require some thinking and they require some writing out of steps. It's kind of a lengthy process. You've got to practice the writing it out to solidify that in your brain so that you can do it come test time. Come test time, you're not going to have to do it 10 different times though. But the practice now is so that's stuck in your head, stuck in your brain so that you can recall it. Work together, help each other. You're going to quiz at the end over day 1 material, which is what we did last class and then like the first couple examples from today. Thanks so much. I'll see you next week.